In this video, we're starting complex numbers. And before anything else, this one and the next three are higher level only. If you're sitting standard level, the number and algebra content finished last video. So, the whole subject exists because of one question that has no answer, until you decide to give it one. Look at these two. The one on the left is fine. 2 squared is 4. Minus 2 squared is also 4. So x is plus or minus 2. The one on the right has no real solutions, because anything you square, positive or negative, comes out positive. There is nothing on the number line that works. So mathematicians did the only thing left. They invented something that does. I is defined as the square root of minus 1, which means I squared is minus 1. And that single fact is the entire engine of this topic. Every simplification you do from here is just spotting an I squared and writing minus 1 instead. So x squared equals minus 4 now has an answer. X is plus or minus 2i. A complex number is written z equals a plus bi. A is the real part, b is the imaginary part. And watch that second one. The imaginary part of 3 plus 4i is 4. Not 4i, it's just the number. Losing the I there is a standard exam slip, and it's worth being careful about from the very start. Now the powers of I. I to the 1 is I squared is minus 1. I cubed is I squared times I, so that's minus I. And I to the 4th is minus 1 times minus 1, which is 1. Then it starts again. So they go round in a loop of 4, which means for any power of I, divide the exponent by 4, and all you need is the remainder. 4 operations. Adding and subtracting is just collecting like terms. Reals with reals, imaginaries with imaginaries. Multiplying is ordinary expanding, and then you tidy up every I squared. The conjugate flips the sign of the imaginary part, and the conjugate is the key to division, because a complex number times its own conjugate is always real. Look, a plus bi times a minus bi is a squared minus bi all squared. And that's a squared plus b squared. No I left at all. That's why division works. You multiply top and bottom by the conjugate of the bottom, and the bottom goes real. Example 1. Simplify the square root of minus 25. Split it. Root 25 times root minus 1. 5 times I. 5i. Now I to the 7th. 7 divided by 4 is 1, remainder 3. So I to the 7th is the same as I cubed, minus I. Example 2. Add and subtract. 3 plus 2i plus 5 minus 7i. Reals. 3 plus 5 is 8. Imaginaries. 2 minus 7 is minus 5. 8 minus 5, I. Now subtract them, and watch the second bracket, because everything in it flips. 3 minus 5 is minus 2, and 2 minus 7 is 2 plus 7, 9. Minus 2 plus 9, I. Example 3. Multiply. 3 plus 2i times 4 minus 5i. Expand all 4 terms. 12 minus 15i plus 8i minus 10i squared. Now the last term is the one that matters. Minus 10i squared is minus 10 times minus 1, which is plus 10. So it jumps across and becomes real. 12 plus 10 is 22, and minus 15 plus 8 is minus 7. 22 minus 7i. Example 4. Divide. 3 plus 2i over 1 minus I. You can't leave an I on the bottom, so multiply top and bottom by the conjugate of the bottom. 1 plus I, top. 3 plus 2I times 1 plus I. 3 plus 3I plus 2I plus 2I squared. The 2I squared is minus 2, so 3 minus 2 is 1, and 3I plus 2I is 5I. 1 plus 5I. Bottom. 1 minus I times 1 plus I. That's 1 minus I squared. 1 plus 1, 2. So it's 1 plus 5I over 2. And finish by splitting it. 0.5 plus 2.5I. Leaving it as one fraction usually costs the last mark. Last one. Solve x squared minus 4x plus 13 equals 0. Check the discriminant first. 16 minus 52, minus 36, negative. Under the old rules, you'd stop right here and write no real solutions. Not anymore. Quadratic formula. 4 plus or minus the square root of minus 36 over 2. Root minus 36 is 6i, so 4 plus or minus 6i over 2. Divide through. 2 plus or minus 3i. And check one of them. 2 plus 3i all squared is 4 plus 12i plus 9i squared. That's minus 5 plus 12i. Then minus 4 lots of 2 plus 3i is minus 8 minus 12i. Add 13. Minus 5 minus 8 plus 13 is 0. And 12i minus 12i is 0. It works. And now notice the pattern. The two roots are conjugates. Complex roots of a real quadratic always come in conjugate pairs. So if an exam hands you one root and tells you the coefficients are real, you already know the other one. So a complex number is two numbers traveling together, and I squared equals minus 1 does all the work. Next video, the same number is written a completely different way, as a distance and an angle, polar and Euler form.